Hey everybody, how you doing? Welcome to the Virtual Night Sky, our version for November the 17th, 2021. We've made it almost to Thanksgiving. We've actually only got 3 weeks of classes left. I can't even believe it. I can't believe how fast the time is moving. And then I think you guys probably remember, as I've been describing what's going on campus, we haven't been open to the public yet, but we will next year. This semester was about getting classes back in the classroom, and we've been very, very successful. So we're almost there. Finals will be the first week of December, and then it's Christmas already. So things are moving so fast. I can't believe it. Tonight we've got a show. I guess it's just going to be kind of done by ourselves. You know, if you've been watching for some time, that we have lots of guests. We have people come in and talk about missions. We have people come in and talk about their science. But we started as a program that just kind of like wanted to talk about the night sky. We started by this sort of mandate that we want to give you things to go out and look at. We want to teach you things on this particular program that you can go out and find on your own from your backyard or your driveway or wherever you observe the sky from. So tonight is a lot about that. So I'm going to walk you through a whole bunch of constellations in the first part of the program. I'm going to take a little break, and Alicia is going to give us a primer on the lunar eclipse. I hope you know there's a lunar eclipse coming up between tomorrow and Friday morning. And then we'll come back to a little night sky thing. We'll kind of show you what's going on with the planets and things like that, and then we'll wrap up. So it's really a show about the stars in your night sky, about what to watch for this winter, about how to engage the sky as you have guests come in for Thanksgiving, and that's how we're going to work with this. Joining me tonight is our regular team. Meg Hufford is with us. She's a colleague of mine, and she and I are kind of in charge of the programming that happens in the facility at ASU. And we've been doing this virtually for a year and a half, and we're tired of it. We're ready to get you back, and we'll do that next year. We've talked about that already. Kim Baptista is our webmaster. She's here with us tonight, and she is the one that kind of organizes this and keeps the communication rolling. And when you register, she's the one that watches that happen and gets everything organized for you to get onto the program tonight. So thank you, Kim. Alicia is now staff. I hope you guys found that transition. She was a student with us, and now she's a staff member, and she's been helping with the virtual night sky ever since the beginning, and so has Alex Blanche. And so Alex is a student. He'll be working in the background. As we go through this tonight, I want to make sure everybody knows the way you communicate with us is through the question and answer button and that function. So I'll be doing this kind of dabbling with the sky, and I'll be in my own zone, and we'll be talking about this and that. We've got some science that's embedded in some of the constellations we'll be talking about tonight. But if any of that strikes a question, or you want to sort of like ask about something, or you need dig a little deeper, please go ahead and use that question and answer button and get that going. Alex in particular, but some others will be monitoring those questions and making sure that they get answered properly. So that's how that works. We do closed captioning in our programs, and it's kind of up to you whether you want it or not. We do that because we post these later. We record them and post them on the YouTube channel, and it just makes it so much easier for us to do this while we're recording. But if it's distracting for you, you want to turn it off, you do that yourself. We also recommend that you do full screen. You have options on how big you want this thing. We sort of suggest full screen. What that does is puts the presentation large and in charge on your viewing monitor, and then whoever is talking will have a little sort of sub screen off to the side. And that's probably the best way to do that. We don't allow chat, but we do have the question and answer. And then I also like to often welcome students. We focus a lot of our programming on K-12 students, especially our outreach programs. And so when we have students on board, we sort of extra special would like them. If you want to use the question and answer button, go ahead and do that. Don't tell us your age or your last name, but you might just say your name and what your grade level is, and then ask a question. We'll make sure to get back to you because we like that. With all of that, I think I'm just going to kind of just get on with the program tonight. We're going to just kind of recover some of the night sky that we started talking about 2 weeks ago. You remember that? Here, let me set up first. I'm going to just kind of start to share the screen. This is always just a little bit chunky because, that's the way it is. And I have to make a couple little movements here. You'll see this in just a moment. There we go. So this, my friends, is one of the programs I like to use, and it's called Sky Safari Pro. And if you've been around sort of watching our programs so far, you probably know that this is sort of the one I prefer and I like to use. There's some others, and Alex is going to tell you about some of the other programs that are available for just kind of desktop night sky planetarium programs. He'll tell you a little bit more about some other ones that are available that you can look into later in the program. But this one called Sky Safari Pro, it's the one I like to use. And the way this works is what you're seeing here is everything that isn't green is above your horizon. So that big circle is your horizon. But kind of bring it up just a little, you can see that the bottom is facing towards the east. And if you look out there right now, you're going to see a big, huge, almost full moon just right above the eastern horizon. If I spin this way, I'm sort of now looking north in my horizon, west. You can sort of see how this works. Milky Way is trailing across the sky. You can see that. Here's a little southern view, and then back to east again. And so I'm going to just start by giving you a big, huge overview. Everything that you see on the screen that isn't in the green area is above the horizon. Now, we live in a big city, and there's always some challenges seeing the stars, in particular, all of the stars that we see in this particular scene. But I'm going to encourage you that that doesn't mean you shouldn't be out there looking. I think that it's very, very important to just kind of keep an eye on what's going on. The ones you can see are meaningful. They will sort of like keep you kind of organized to where you're looking, what you're looking at in the night sky. And I think that's really sort of important to do. So don't give up, keep trying. I'm going to show you some things tonight to look for. I'll try to point out as we go along the ones that are going to be a little tough in the city lights. And I'll point out the ones that are probably really, really easy to find and easy to see. And I hope you enjoy the program tonight. We actually have been kind of talking about doing this for a little while. It's a program we did last winter because there's some stars that I just like to talk about in the night sky. You'll see that I got a little pen here, and I like to use that. And I'm just going to just trace out for the moment the area of the sky we're going to be dealing with at first. So I'm going to go all the way around this way, up this way, over this way, and down this way. So a significant amount of the night sky. And within that little circle I just drew is 6 constellations. There's actually more than 6, but there's 6 that we're going to talk about. And they all tell a story. As I introduced it last week, I said, this is really the story of the sacrifice of Andromeda. And you remember, and we'll talk it through, but it involves Andromeda, the daughter, her parents, the king and queen of Ethiopia. Perseus is the hero that comes to rescue her. There's a sea monster involved here and a winged horse. So 6 characters that all make up this particular thing. But embedded in those constellations are also some really interesting things to know about, some stars that sort of just have special meaning scientifically to us today, and some other objects that are in there. And so I'll point that out to you today. I also wanted to point out that last week when we started this, right, we were going to try to cover most of this thing last week. We just ran out of time, or 2 weeks ago. The moon wasn't there. The moon was a new moon. Right? So this is one of the things that happens to us. Every 2 weeks is about 14 days, and every 14 days is about half the cycle of the moon. So we tend to do our Wednesday programs when the moon isn't in the sky, and then the next Wednesday program we do 2 weeks later, the moon is large and in charge and is blocking some of our views. So this really story tonight, and what I'm going to show you tonight, is supposed to be good for a while. You'll be able to see these constellations all the way through the rest of November, well through December. If you take the time to go out and look and start to sort these things out for yourself, I think it'll be very, very important. Tonight, if you go look at some of these things, the moon is going to really block a lot of the sight of your seeing, and kind of like be a little bit of a problem. So just back to I'm just going to I'm going to just go to the first 2 characters in our program. We started to introduce these 2 weeks ago, and just zooming in just a little bit so I can get the first 2 characters into view here, and I'll show you what this looks like. This right here is Polaris, the North Star. And that's just a frame of reference. I think everybody can find the North Star. Most people know how to do that. It's always in your night sky. And it's a really good place to start this journey because the North Star is viewable, it's visible, and it's something you can see in the Phoenix area. Just above here, right here, there's a constellation or a little grouping of stars that looks a little bit like an upside down steeple or an upside down house. You sort of see it there. And this is actually a constellation called Cephus. Cephus is the king. Cephus is the father of Andromeda. And he just sort of lives in this particular part of the sky. The queen is actually marked over here. And everybody's sort of, this is really an iconic constellation. Most people know this one, but the one that's sort of shaped like a W or an M in the sky, depending on which direction you're looking at, you know that as Cassiopeia. Ancient people sort of thought about it. She is the queen of Ethiopia, not the Ethiopia we know today. It was a sea coast kingdom, and it doesn't really have anything to do with the current Ethiopia, but mythology describes it that way. And these two constellations are going to start to set up our story. I want to just show you something here real quick. And so within the W of Cassiopeia, and I can't remember if I actually got this far 2 weeks ago or not, but I wanted to point out a star. I kind of call it the sixth man here. It's not one of the 5 bright stars that make up the W, but it's another one. And it's actually, its Greek letter is eta. And so it looks like a little N here. And then I'm just going to say, oops, I'm going to write Cassiopeia here. And so then so you would know it. The reason I point out this star is when I do star talks and I do parties and I have people out in the night sky, I kind of have them focus on this star because it really is very, very close to the same size as our sun. And it's the same color as our sun, and it's the same what we call luminosity. You're going to hear that term a couple of times tonight. So where it is in space, it's giving off light, it's doing its star thing, and it's very similar in luminosity to the sun that we have, our sun, and it's about 20 light years away. So that doesn't seem that far anymore. Now, of course, it's impossible for our technology to take us there, but 20 light years is close enough to know an awful lot about stars, an awful lot about what they are and how they work in space. And this particular one is, again, the same size and same brightness as your sun. So if you were there, if we can sort of kind of transport ourselves, move out to Eta Cassiopeia, you could actually sort of turn around and look back. Our sun would look like that. Our sun wouldn't be anywhere near the brightest star in the sky, and probably not even the more interesting star in the sky. We're kind of common. And so this particular star is just a real good sort of just general frame of reference. You probably haven't done this before, but find the W, find that sixth star, the one that isn't part of the 5-star asterism, and the sixth brightest star in this constellation. And just think about that. Think about what our sun would look like if we were star travelers and we're 20 light years away and turning around and trying to find us and what's important about our sun and what's going on over there. So I always like that particular sort of like part of the story. Cephus, though, has some science behind it, and we got to go into this. So you probably have noticed that I sort of described this first as like a little upside down church or steeple or something like that. And that's how it appears in the night sky tonight. One of the corners over here is actually not a single star, but 3 stars. Can you see that little triangle of stars? That they're like an isosceles triangle, right? The important one here, and it actually might be, some could argue, it might be the most important star scientifically in your night sky, is this one right here. Right there, that little guy right there. And so it's called Delta Cephei. And so remember, Eta Cassiopeia, Delta Cephei. The way we do this, a real simple naming convention was to use the Greek letter. Usually the alpha is the brightest in the system, then beta, gamma, delta, as you sort of like you do that. So Delta Cephei, theoretically, that would be the 4th brightest star. It's a variable star, and you'll notice its 2 companions up there. One is a little bit dimmer, this one, and one is a little bit brighter, this one. And what was noticed a long time ago is that delta Cephei actually changes brightness in a very, very short period. It doesn't take very long. It's only a matter of days. I'll show you a chart in a second. And so when you look at it, sometimes when you look up there, it will be about the same brightness and look like this star. And other times you'll look at delta Cephei and it'll be a little bit brighter and it'll look like this partner over here. Here's what happened. I'm going to stop this share for a second and give you guys a little look at what this looks like. So this is essentially what we call a light curve for delta Cephei. So you see delta Cephei up there in the corner in the brightness, and you can see that at its maximum, it's about 3.6 magnitude, and that makes it a bright enough star for you to see for sure, for sure. In fact, you'll see both ends of this scale. And notice that that period is not very long, but over 5.5 days, 5.4 days, it drops slowly down to a little bit about 4.3 magnitude. And remember, magnitude scale goes backwards. So the higher the number of magnitude, the dimmer the star. It means a first magnitude star is bright, a second magnitude star is a little dimmer, and down. We can see in a good clear night sky down to about 6 or 6.5 magnitude. So these are very observable, and I know I can see them from the Phoenix area. So, depending on conditions and all that stuff, but this is really important to see. So it dives down a little bit to this lower magnitude, and then it jumps right back up again. And people have noticed that this happened. Here's the trick to this. Wise scientists figured out that actually there's a correlation between those cycles. So remember, delta Cephei has about a period of about 5 days. You can actually see, if you know the days that the period lasts, you can actually see on this chart how bright delta Cephei variables are where they are in space. So this became a really tight class of a star called Cephei variables, and they became very important because they're announcing to you, if you follow those cycles, those periods of variability, how many days it takes them to do their little cycles, you can tell how bright they are, where they are in space. And if you know that, then you can tell how far away they are, because we know how much light diminishes over distance. So you know how bright it is where it is, you know how bright it is where we are using instruments and telescopes and instruments, then you can very accurately say exactly how far away a Cephei variable is. That became really important because we use that kind of thing to measure the distance of a user. So if you see on this chart, on the left-hand side over there, parallax, right? That is actually just looking at a star at different times of the year. When the sun is over here, you look at it. When the sun is over there, you look at it. And you can actually see a little bit of movement, right? That's called parallax. And that's a very, very accurate way to determine star position up to about 100 light years away. And that's close to us, right? And that's the video. But then the distance after that, we count on understanding Cephei variables, and they are embedded in clusters, they're embedded in galaxies, they're embedded in other objects, and we know how bright they're supposed to be. We can tell how far away they are, and this is our way to determine the distance to galactic observations all the way up to about, about 10,000 light years away. And then towards the upper right side of the screen are various other ways to sort of do these sort of standard distance scales for much deeper objects and things like that. But Cephei variables covers a huge part of our nearby universe, and it allows us to know very accurately how far nearby galaxies are. You're going to meet one. See down at the bottom of the screen, the Andromeda Galaxy? When we get to Andromeda, I'm going to show you where that is. Let's remember that we talked about Cephei variables, and the reason we know the distance to that galaxy is because of this particular very, very interesting type of star. So there you go. In the sky, oops, I'm sorry, didn't mean to do that. Go back. In the night sky, you have this ancient story, these constellations that sort of are about this ancient story, but embedded in them is some really cool science. All right, introducing Andromeda. She probably is the bigger star of the show. I'm going to give her some hair here. She has this really long, beautiful body right here. She's wearing a dress. I'm going to make that happen. And then she has one arm stretched out this way, one arm stretched out this way, and she is chained to a rock. What happened? What befell this poor young lady to make this particular scene happen to her? Well, it goes back to Cassiopeia, the queen. She is boastful, and in the day, you're not supposed to do that, right? You could really, really make the gods angry if you bragged. And so one day, Cassiopeia was talking to her husband, and she says to Cephei, she says, "Aren't I the most beautiful queen in the world?" And Cephei says, of course, what's he going to say, right? He says, "Of course you are. Yes, you are the most beautiful queen there is." And then she went on to say, "And our beautiful daughter Andromeda, isn't she wonderful? Isn't she the most beautiful thing that has ever graced the heavens? Isn't she more beautiful than the nymphs in the sea?" So I'm going to put her like in her little throne over here so you can see where the queen is. Isn't she? And the husband says, yep, absolutely she is. Well, that was a step too far because the nymphs and the sea nymphs were actually the property of Neptune. And he knows how beautiful they are, and he knows no mere mortal, nobody on earth could be as beautiful as the nymphs in the sea. So he got angry. He went to the king and queen, Cassiopeia and Cetus, and he says, "You guys got two choices. You can allow me to just roil up a typhoon and wipe out your land completely, everybody gone and nothing left. Or you can sacrifice your sea monster, or you can sacrifice your daughter to a sea monster." So I'm going to kind of put a little king over there. Cephei, Cassiopeia, and Andromeda. And there they sit in your scene. And so what do you think they chose? I mean, they had two choices, right? So they wanted to see their lands and their whole country wiped out by a major typhoon. And Neptune can do it. If anybody can do it, he can do it. Or do you sacrifice the girl? No, of course, that's what came to be. Andromeda was then tied to a rock. And the story goes that there was this huge, huge crowd gathered on the cliffs above the thing. They were like cheering and laughing and crying and yelling and all of that kind of stuff. And there she is, and she's whimpering, and she's it's just kind of a situation out of control. We need to have a sea monster. And we happen to have one. I'm going to change scenes here a little bit. Got to move over just a little tiny bit. So here's Andromeda again. So here's her sort of like long legs, her arms tied to the rocks out over here, all that kind of stuff going on. And then just right below her here, this particular area right here is a really, really gnarly sea monster with big, big, gigantic teeth. And he is sort of like coming out of the water. He comes up this way. He's got a dorsal fin over here and a big, huge fin thing back here. And little tiny fins down here, big mouth, big teeth. He slobbers a lot, and he's just sitting every day. This constellation is called Cetus, and Cetus is a whale sometimes, a kraken sometimes, a sea monster other times. But it just sits right there. And look at it, it's staring at the moon tonight. That moon will be in a slightly different position tomorrow. So here the scene is going, right? The whole crowd is watching. This sea monster is coming out of the sea. It is getting closer and closer and closer. Andromeda is helpless. She's crying, and everybody's sort of like getting this anticipation that she's just going to kind of get eaten by this big, huge, toothy monster coming out of the sea. But somebody comes to the rescue. Who is it? I think everybody knows that part of the story. And let me just show you something else going on here. I need to take a little science break. Hang on a second here. One more movement. Right in here, remember Andromeda? I wanted to show you something. This particular star is her head, and that star is called Alpharazz. And she's right here. And then if you follow this, just basically two lines of stars that kind of go down and just form sort of the shape of the body here. Here's what I like to do is come down two stars this way, 1, 2, and then go up 2 stars this way, 1, 2. So you start at her head, 1, 2, 1, 2, and you're going to sort of like find in a really nice clear sky, there's a little fuzzy patch right here. In fact, even with the unaided eye, you can see it's a little bit of an oval kind of fuzzy patch in the sky. That, my friends, is what we call the Andromeda Galaxy. And that is my next slide. So here you go. Here's how I did it. Remember, I started at Alpharazz. I came down 2 stars to Mira, and then up 2 stars, right? Just so they're like passing. And this little circular or elliptical little shape right there is the great Andromeda Galaxy. The Andromeda Galaxy is the furthest thing that you can see with the unaided eye. So when you get out into a night sky, when you get nice, clear, absolutely dark skies, when you get sort of that ability, you can find this thing. Once you have found it, it's really hard not to find in the future. You start with that great square. We'll talk about that. That's Pegasus. The eastern corner of it is the head of Andromeda called Alpharazz, 2 stars down, 2 stars up. And there it is. And you can see that. It's about 2 million light years away. So almost everything you see in the night sky, almost everything, all the stars we're talking about, all the stars that make up these constellations are within about 1,500 to 2,000 light years. That's close, 2,000 light years from you. That's about as far as you could detect a star in the sky. The central core of the Milky Way, and the Milky Way as a band, is seeable, but you're not resolving stars. You're just seeing the combined light of billions of stars out beyond your local constellations. This is way out there, 2 billion light years away. And that's, 2 million light years away. Andromeda Galaxy is also determined, we determined the distance with great accuracy using Cephei variables. So we can examine this galaxy. It's close enough that we can identify with telescopes, right? It takes major telescope technology to do this, but we can identify Cephei variables. And then with that chart, with that way I described, we can tell how far away this is. So really, really important part of science and understanding the night sky. There's one more star I want to show you here, and it is another type of variable. And it is in the constellation Cetus. This is actually, unlike Delta Cephei, which has like a little 5-day period, this one has a really long period, and its name is Mira. Mira is a variable star that has a dramatic drop in brightness. At its brightest, let me show you a chart, I guess. I have one right here. Hang on a second. I can do this. So you can see on the left-hand side of this thing, you can see that it's up between 2 and 3 magnitudes when it's at its top brightness, and then it shrinks down to about 9 or 10 magnitude. Remember what I said before, the higher the number, the dimmer the star, and so it drops dramatically down. This is actually on about an 11-month cycle. Not like 5 days like the Delta Cephei, but 11 months, and the magnitude drop is significant. It drops down to a point where you can't see it. For part of its time in the sky, between those peaks, it's an invisible star. You can't see it, right? But there are 11 months out of the year. I mean, every 11 months for a period of about a month or 2, it's a very, very bright star in the night sky. Its name is Mira. And what's happening is it's off-gassing shells, and so it expands in size. So if you take the same amount of energy and cover more space, right, then it becomes cooler and then therefore dimmer. Eventually, the inside, which is now hydrogen, re-sparks and starts to get very hot. It shrinks again back down to a really, really tight compact thing with lots of hydrogen fusion going on, and it increases in temperature and less surface area, so it becomes very bright. And it does this on a regular cycle, and we've been observing this for hundreds and hundreds of years. We think this has been going on for 100,000 years. It is a star that's a little bit more massive than the sun, but it is sort of doing this cycle, and these are the last throes of its life. These are its death throes. Once it starts burning up, it stopped burning hydrogen, now it's fusing helium. It's got a carbon-rich core because it's making carbon in the middle. Once all of this starts to happen, the end is near, and eventually it will off-gas, it will exhaust all its hydrogen, shrink into a little sort of shriveled core like a white dwarf, and that will be the end of the star. It is also the end of our sun. That's how that's going to happen, but we think this is going to happen within the next couple million years. Our sun will last another 5 billion or so, but this is how stars of the size and class of the sun do this. One more quick little slide here. Let me just show you when those bright cycles are. So we just had one August 18th. That would have been a really bright star in your sky if you could find it. And the next time it'll reach that same kind of magnitude will be July the 16th, in the middle of the summer. And then, like I say, these are 11 months. It's actually 331 days apart. Bam, 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 bam. A very, very exciting, interesting star. And it's helped us understand essentially the life cycle of stars in general and what they do. And for our story, it also happens to be embedded right in the sea monster that's about to eat Andromeda. I'm going to have to sort of like bring the hero into the show, and then I'm going to take a little break. And then we'll sort of like close it out, something just right after that. Over in, let me see, I'm going to do blue over here. Over in this little area is our hero. His name is Perseus. And Perseus is just getting back from a journey where he went, and you might know that he was supposed to find Medusa, sever her head, and bring it back. Medusa had a very, very special property that she was actually able to turn people to stone if you looked at it. You guys remember the story, right? And so Perseus is usually sort of like shown as a superhero, a kind of action character walking through the sky. And he is actually on his way back from that task. So in here, we actually also have Medusa's head. And you remember Medusa was very, very ugly. She had snakes for hair. So I'm going to kind of give her some snakes over here. So within the constellation that we call Perseus is not only the action figure himself, Perseus, and he's got, I probably sort of didn't, I hope nobody's grading me on my artwork, but sort of, let me see if I can get this arm a little bit better. And so kind of down at his belt line, he's actually holding the head of Medusa. As he's traveling home, right, he sees this whole action going on below him. There's Andromeda, she's chained to the rock. There's the sea monster. Here he comes out of the sea, and the action is getting hot, and she is about to just be eaten up. And here comes Perseus, and he has a brilliant, brilliant idea, and we're going to come back to that after a break. So we're going to take a little bit of an intermission here. I'm going to stop screenshot. I am going to stop screen share for a moment. And I'm going to introduce Alicia Hyatt, because we were talking about today, and we can't let this particular virtual night sky get by without telling you all about this eclipse that's coming up. It's really overnight tomorrow night, so early in the morning, Friday. And Alicia will tell you all about this eclipse and how eclipses work and how that works. So thanks, Alicia. I get to take a break and have a drink of water. Oh, okay.
Yes, but before I go into that, I just want to propose that we change your name to Ricasso.
I think not. I think that's an insult to every artist that has ever lived. Okay, but thank you.
I thought it was great. Wonderful. So what I'm going to do now is share my screen. And as Rick, oops, am I sharing the wrong screen? Let's see here. Give me 1 second here. Rick, can someone tell me what you're looking at here?
Nothing yet.
Oh.
Alicia Hyatt is screen sharing.
Huh. Interesting.
Might have to give it some time.
Just give it.
Let's see here. How about now?
There you go.
Oh, third time's the charm.
Lunar eclipse. Yep, lunar eclipse. You got it.
Okay, perfect. Technical
Lunar eclipse.
Lunar eclipse. Yes, I'm here to talk to you about a lunar eclipse. And as Rick mentioned, very exciting news happening this week, right now in your own backyard, or if you're local here in Arizona. And so on November 18th, so tomorrow night through the morning of the 19th. If you live in Arizona, you most likely will be able to see a partial lunar eclipse. And if you're wondering what a lunar eclipse is, or if you have questions about it, I'm going to go ahead and play a NASA video that's going to explain it a lot better than I can. So I will start that now.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although the Earth and the moon always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
All right, thanks NASA for that great explanation. Let's move past that. All right, so this partial lunar eclipse, as I mentioned, starts for Arizona time. So we're gonna look over here in this Phoenix category. It starts at 11:02 p.m., right? We're not gonna see too much at that time. Really, the peak time is going to be about 2 a.m. And I know that's super early, but I definitely think it'll be worth staying up or waking up for. So make sure you grab your coat, make sure you go outside about 30 minutes early, let your eyes dilate, and you should be able to get a decent view barring any weather restrictions. And if you're wondering what UTC time is, it's the time that the world it regulates on, it runs off of. So it's kind of a standard time, and you can convert it to your standard time zone. But for the Phoenix category, like I said, it starts around 11 p.m., but we're really going to see a peak at about 2 a.m. So yes, it's going to be visible in Phoenix. I highly encourage you to stay up or wake up for it, and let us know in the comments or in the Q&A if you plan on staying up, or if you did, what you saw. So. With that being said, you can tell us at our next show what you saw.
That's what I was just gonna say. And so my rule of thumb with UTC, right, is to -7. So Phoenix is UTC -7. So a lot of events that happen that sort of, have a specific time, the scientific community will use that. It also happens to be Greenwich time, right, in London, England. So Arizona, you should think, is UTC -7, and it all kind of works out. And then also want to say, we'll talk about this maybe at the end, but there is another total lunar eclipse early next year, in May next year, and it will be much better positioned to see in the evening. It's going to be a prime time event, so start more like around 11 or 7 and end something like midnight. So that'll be a little bit easier to watch. But I encourage everybody to get out and do this. And you've heard me over the years, right, say you gotta take advantage of these things. They don't happen very often, and it's not that much work to get out of bed and get your snuggly warm clothes on and go and just take a peek. It'll be beautiful.
Yeah,
It'll be
really
really, really rich red. So that'll be kind of fun to see too. And then I'm going to ask, we'll have a poll 2 weeks from now. I'm going to ask how many people went out and looked at it. And so we're going to put you on the spot. You're going to have to answer. Okay. Alicia, would you launch some polls too? I think we got 3 polls. I don't know who's going to launch them, but I just wanted to sort of just cover a little bit. You know, I guess we're going to have to wait for the last one at the end. So I'm going to do poll number 1 and poll number 2. And so this one, short period variable that helps determine the distance in space, right? We talked about this, didn't we? People are sort of getting this. This is good. Some people want it to be all gold. No. Okay, it's settled down. You're right. 80% of you have this right. So delta Cephei, sometimes delta Cephei is a type star, and the term we use is Cepheid variables. And when we can find one of those and measure its pulse rate, it tells us something about its brightness. When we know its brightness, we can tell how far away it is, and that's really very, very good. Okay, let's do poll number 2. This star is a long period variable with a wide magnitude range. So yeah, okay. So people just like jumped on it. That makes sense. And you know the difference. One of them is in the constellation Cetus, the king. And the other one is in the constellation Cetus, the whale or the sea monster. So that's very, very good. Okay, let's end those. I'm going to go back and I have one more poll question for you at the end, but we didn't get to its star yet, so I guess we have to like wait for that one. So, so this just takes just a second to make this thing work, right? But thanks, Alicia, for that thing about the moon. I think that's great. I thought I had myself convinced that this was going to be one that we couldn't see at all. I didn't realize that, of course, it's just a morning thing. So we're there. Where were we? I think, if I remember right, we had Perseus flying over, and he's just about to drop in and do his thing. I won't redraw the whole thing, but I will sort of put the head of Medusa back on the screen here so we can sort of see where she is. And a couple little snakes coming out of the thing here. And so I think you guys know the story. What happened is Perseus sees this happen. Andromeda is drop dead beautiful. So he just jumps down to save her. He gets in between her and the sea monster. He pulls out the head of Medusa out of a little bag, shows it to the sea monster. That giant kraken instantly turns to stone, and the whole party is over, right? And so saved her. Everything is kind of going to work out. And then they go flying away. What do? They sort of take off into the sky and live happily ever after, I suppose, or at least until their next adventure. So we need sort of a flying horse here, and I think I have one in the night sky right here. So just to kind of get everybody sort of resorted out here. One second. Here is Cetus the king and the delta Cepheid variable. Here is the W that makes the queen, Cassiopeia. This sort of chain of stars over here that goes this way and out this way is Perseus. And this 2 long sort of sweeps of stars that come down this way is Andromeda. The sea monster is down here. The last character in our story is marked by this giant square. Sometimes we call it the Great Square. We call it the Great Square of Pegasus. Mariners in the old days used to call this Mariner's Square because it happens to rise exactly in the east, set exactly in the west. And it's a very, very recognizable asterism all on its own. So it's really cool. Sometimes it's fun to go out and look at that Great Square and see how many stars you might be able to see inside, because then that's a measure of how bright your night sky is, how your seeing conditions are at your particular place. If you can see 4 or 5 stars within the square, then you've got really, really great seeing conditions. And so most people in the city of Phoenix maybe can't do that, maybe just 1 or 2. But the head of this great horse sort of comes out this way. And so I'm just going to try to draw a little head here and give him an eye and some ears. Don't horses have little ears that stick up? And we'll sort of bring his mane back this way. His front legs are prominent and they stick out in this particular direction. This is essentially the body of the horse over here. And I want you to notice something here. Remember the head of Medusa is right here? I'm sorry, the head of Andromeda is right here. That's Alpharazz. Alpharazz and Syrah is the name of the star. It has two names, and it has two of those designations. Not only is it Alpha Andromeda, but it is also Delta Pegasus. And so it's sort of shared through time. When the astronomical union sort of put all this together and designated boundaries and what belongs to what and everything, Andromeda got this particular star. So now we consider it part of the constellation Andromeda. But for most of us old timers that remember the old days many, many years ago, this is a star that actually belongs to both constellations. And so that's where Pegasus is. Now, there's one more thing I sort of have to show you here to sort of just kind of close this story. But I wanted to kind of just get back down here and remember Medusa. This is Perseus right here. Medusa's head, let me say, I've been using green. So if I sort of draw it really big right here, here's her sort of like, here's sort of her ugly eyes. Here's sort of dangly ear things. Medusa, of course, also had snakes for hair. So that was pretty ugly. She was actually sort of like a wreck, right? So all that stuff. This particular star right here is one of the most fascinating stars in the sky. Its name is Algo, and it is actually a variable again. And so part of this story tonight has been about variable stars, right? This one is something of a totally different character. Right? Remember, Delta Cephei was a fast period but pulsing star where it's sort of like dimmed in brightness intrinsically and it gets brighter again and does that sort of on a regular basis. Mira, we talked about long period variable, same thing. There's a process going on that makes it expand and contract and all that stuff. This particular star is what we call an eclipsing binary. And that means that there are two stars up there and one passes in front of the other. And that allows it to actually do this little dim here. This is really the cool part. Let me just show you a quick little sort of thing about this. This is the light curve of Algo. You'll see basically there is a smaller, brighter, hotter star in front. That's Algo A. Algo B is bigger, dimmer, right, and also more massive in the back. And so B rotates, orbits around, and sort of like moves past the face of Algo, and you see this dramatic little bright dip, and then it just pops right back up again. So this particular variable is characterized by holding essentially a brightness level at about 3.2 magnitude. So it's bright enough for you to see in the night sky for sure. And then it'll drop almost a full magnitude just for a brief period of time, about an hour and a half or 2 hours. And then it comes right back up again. And then it'll hold that steady pace for a little bit over 2 days, two and almost 3 days. And then it'll drop again and do that. It's also Algo A is a little bit reddish. And it has always been associated with the eye of Medusa. In fact, ancient people call this the demon star or the demon eye. And because of these characteristics, and because this would have been known, this would have been observable thousands of years ago when these stories started generating, when mythologies first started to happen, and this whole sort of story about Andromeda and the sacrifice and Medusa and Perseus, all that stuff starts to roll out. People recognize that this particular object had this very, very strange and evil, if you want, property, but being able to wink at you. And we sort of, and known as the demon eye. I think that's really wonderful because today, of course, we know what makes this happen. There's an explanation for the demon eye. But think about sort of how we have observed the stars over thousands and thousands of years, and the stories told and how they're passed down. Right? This particular story just repeats itself over and over again. About 10 years ago, a movie came out, right? Remember the, what was that called? The Clash of the Titans. And it's exactly this story told for thousands of years in these particular constellations in the night sky, and they're part of your winter. And so I encourage you to sort of remember some of this science, remember some of these things to look for. Let me just sort of go back and show you where to find that eye and where to find some of these other stars. So here is Perseus. Another good way to find Perseus, if you sort of like need to know, is right below it. Let me sort of screenshot so I can get my pens back up again. So right down here, you probably might recognize this. This is the head of the bowl of Taurus just coming up. Actually, it's 8 o'clock now, or by the time we get done here, you can go out and see Taurus will be well above the horizon. This little sort of thing right here, it's not very clear on my screen, is the Pleiades. Remember the little 7 sisters? And so if you find this, these are fairly bright stars. You just look at this big, huge trail of sort of stars. It's fairly easy to find. It comes down like this and sort of like some characters that go like that. And then this one, the second star from the end, this one right here, here's the end star, here's the second star. That is the demon eye. That is Algo. And if you look at it at the wrong time, that star's going to wink at you, and then you're in trouble because you never know. You might just turn to stone. This is sort of something I invite you guys to go sort of like check out in the night sky. It's fun to watch. Get yourself a little star charts or program if you need help finding around. You won't see a lot of all these little sort of individual stars in the middle and all that kind of stuff. Cassiopeia is easy to find, easy to see. Cetus is not so easy to find, but you can sort of pick it out if you know, if you kind of like are careful. And where you look, the Great Square is easy to find. The trail of stars that create Andromeda up there, fairly easy to find in an evening sky. You need pretty good conditions in Phoenix to see Andromeda. You need really, really good conditions to see the Andromeda Galaxy, which is really like part of that. So some are easy, some are hard, but the 6 of them together kind of create this incredible story that's been handed down over years and years and years and years, and I deliver it to you tonight. So that's that. I don't know if over the course of my talk tonight, if we've generated any questions. Because I'm not following that part of it, but if there are any, this would be a good time to answer it, and then I'll sort of turn you over to the next part of the program. Anything going on?
Well, we've had a lot of questions about the lunar eclipse.
Okay, good.
I mean, I guess one of them. This is kind of for everyone, but I'll ask you, Rick. Are you gonna watch the lunar eclipse?
I definitely will. I don't think, just to be honest, I don't think I'm going to sit out in the backyard for 5 hours. But I sort of got gas for my little fire pit, and I got a little setup out there, and I know where it's going to be, so I can kind of like do this. The moon will be just directly to the south. So if you've got a good view of the south, and it'll be highest when it begins. So the start of the eclipse, somewhere around, when was it, as Alicia said, 11 to 12, 15, when it sort of starts to move into its eclipse mode, it'll be directly south. And then it'll just sort of move towards the west over the hours. And so by the time it's a full eclipse, you're going to want a view of the southwestern part of the sky. The moon won't be at its highest, but it'll certainly be well above the horizon. So that would be the place to get organized. I think what I'm going to do is just maybe set a little timer clock or something like that and get up every 90 minutes and go take a look and then go back and get warm again. So what about you, Alex? Are you going to do it?
Yeah, I'm usually up at that time of night. So yeah, I'll definitely be on. I mean, it'll be like totality by my bedtime. So I think I'll be able to stay up a little bit longer.
So some of us talk about that as being late. Some of us talk about that as being early. It depends where you come from. So that's really good to know. All right. Yep. Anything else?
No, we've had some questions about the evolution of stars, but those have been answered in chat. But yeah, just want to check in and see if you're going to watch that.
What I'd like you to do then, if you don't mind, I think we talked about this a little bit ago, is we have some planetarium resources. So I'll again repeat, I like to use a program called Sky Safari Pro, and it costs just a little bit of money, not very much. It's like $20 to get it downloaded onto your thing. It works for me, but a lot of them have cool features and wonderful things. And so did you have another couple you wanted to show, Alex?
Yes, I do. Yeah, let me share my screen. Let me talk about this first one. This is one that I think we've actually showed on this program a few times before. I just want to reiterate it because it's a great program. It's called Stellarium. It's available on a lot of computer-based systems, Windows, Mac, Linux even. It's a great system. There's also a web version that you can use in browser, Stellarium Web. I recommend you check out any of these. Stellarium Web is really easy and quick to access, but the Stellarium program has a bunch of really fully fledged out and developed features that you can use for a lot of stuff. Great program for viewing what your night sky is going to look at, when, where. It's not even limited to Earth. You can view what the night sky will look like on other planets. It's a really incredible software, so I highly recommend you check it out. Another one that I am not entirely familiar with, but I heard from some people, is Carte du Ciel. So more of a sky chart.
It means chart of stars, and it's this one is European. It's also free, or at least it was last time I did it. And I've used this before. I did it to sort of like do some like more research, angular distance between stars and something like that. I had some projects one time, and this one actually fit the bill, so I kind of liked it. It's also, this one seems to be more printable. So if you want to print star charts, this is where I would go. So just to sort of like, you know, do something, find something, and then drive it through your printer, because it actually has a white background and colorful star things, and it's a lot easier on the printer.
Yeah, as far as I'm aware, I haven't found that feature in Stellarium. It might well be there, and I just haven't dug deep enough. But yeah, this seems more like a more of a reference material kind of program. And then finally, we have kind of what you mentioned, Sky Safari Pro. This is another great app. This is not free, but this is another great planetarium app. So be sure to check those out. Stellarium.org or stellarium-web.org. That's the web client. And then this is actually www.ap-i.net. That's who develops this. And then skysafariastronomy.com. So be sure to check those out if you're looking for a planetarium software for you to use and see your own night sky. And those are our resources.
So I also, just as you probably noticed, I like to just little sketch and draw, and I'm not very good at it. But what I do is I kind of figured out you can do really quick screenshots on an iPad. That's what I use. And so I do little quick screenshots, and then I have one of those little Apple pencils, and I can sketch and draw and all that stuff, and do that kind of thing. So anyway, it's kind of fun. It's also it's a way to just doodle away time too. So just like learn where all these stars are, and sketch their relationships. So that's really cool. We wanted to talk about just two current things that are very, very important for us to share for you tonight. So I'm going to invite Kim to the screen. She's going to tell you a little bit about the wrap up of a project we've kind of been talking about for about half a year, haven't we? So, but your last chances are coming.
Yes, so I know we've been talking about it for a while, but you have about 10 days or so till the Arizona Historical Society wraps up their exhibit, and I'll put that up on the screen here. The Ready to Launch Arizona's Place in Space down in Tucson. It's been a great exhibit. We've heard lots of great things, and it's coming to a close on November 30th. So I would suggest, if you have an interest, maybe make a trip down there this coming weekend before it closes on November 30th. And with that, Rick, I'm going to advance the screen, and I'm going to let you take it away for the next upcoming event.
Sure. So we don't do this very often, but I do want to, just a couple of times a year, I just kind of want to remind people that the outreach program and the program that, you've gotten to know us now quite a little bit, and the team that puts these things together, the outreach program at the School of Earth and Space Exploration and the work that we do has really a kind of a whole different kind of funding system than anything else. We can't use tuition dollars to do this, and we can't use necessarily mission or research or NASA or sort of granted dollars through research programs to do what we do. So we really kind of are dependent on the community and dependent on those people that sort of think this is really wonderful, and the things that we do in the way of engaging the public in outreach. So I just wanted to sort of, you don't hear from us do this very much, but at the School of Earth and Space Exploration, we're really proud of our students, our faculty, our staff, and really we're proud that we've been able to engage the community like you, get you involved in our particular program. The support we get from people like you allows us to accomplish a whole bunch of things over the last couple of years, right? We didn't even know how to do a virtual 18, 20 months ago, right? We were all thrown into this together last March, and it didn't take us more than a couple of weeks to know we had to come up with something. We had to come up with some idea that was going to keep our friends and keep those people that are following us in a live format. And how were we going to do this over the course of the COVID? Had no idea how long this would last or what we'd be doing, but we just engaged right away. And the team came together and said, okay, it doesn't matter what we did before now, we've got a new way to do this. And really it's because of the community, because of your support, because of the way we do this. So Tuesday, November 30th is what we call Giving Tuesday. And you probably are hearing from all kinds of your nonprofits and all of the friends that you have had over the years. This is that time where we do this. We want to make sure that you know that we can do this too. And so Giving Tuesday is November the 30th, and we invite you to participate and consider a donation to the School of Earth and Space Exploration. There is a little web thing there, so you can get into it. You can find out what that is. Kim is also going to include that link in a email that's going to go back out to you. It's the one that you get 1 to 2 days after every one of our VNSs, but we'll make sure that we have that particular link. And that just sort of invites you to think about us and think about the opportunities you've had to sort of engage with us over this last year and a half. What an adventure we've all had. We can't wait to get back in public, but we know that we've learned from the virtual sky programs that we've done and the reach that we have through this thing. We're actually going to go back and do both. That's one thing that the COVID pandemic has brought to us. We're not going to go back and just stop doing this. We're going to use both tools and both technologies and both ways of engaging our public going forward. So that just makes it a little bit tougher on us, but we want to do it. And so think about that if you don't mind. Our next program is 2 weeks from tonight, and that will be the last one of the year. We have decided to call December the 1st, the last Wednesday that we're going to use this year. The next one would be really kind of too close to the holidays. And so we're going to skip that. We'll be back in January. Don't worry about that. But in the last program of the year on December 1st, we've been kind of engaging in this idea. We're going to talk about the 10 things, the top 10 things that we're looking forward to going into 2022. And the more we worked on this, the more we put these little charts together, so to say, okay, what are these 10 things? How do we classify the 10 most important things that are going to happen next year in our little universe? We thought that this is going to be really good, and I got excited about it. And we've got some exciting things to share with you coming up. And it's a really, really great way to finish our year and kind of just take a little breather, enjoy the holidays, give our students a break. And then we actually picked a date for resuming, but I can't remember what it was. I think it's somewhere around January 11th, if I remember. There's another event coming up. You saw it. We talked about it 2 weeks ago. It's coming along. But we are very, very much looking forward to the launch of a spacecraft and the James Webb Telescope. So the James Webb Space Telescope has been a long time coming. It will launch on December the 18th, and we will be broadcasting that live. It's also an early morning thing. We believe the launch to be about 5:30 in the morning. It's a Saturday. It's December 18th. We're going to actually broadcast that live from Marston Theater. We'll be doing NASA feed and talking to experts and scientists at ASU as we do that. So if you're looking for us, December the 1st, 2 Wednesdays from now, a program where we're going to share with you our view of 2022. And then December the 18th, we'll all be celebrating the launch of the James Webb Space Telescope. Thank you for joining us tonight. I hope you had fun tonight. I had a lot of fun tonight sharing the story and sharing the science behind those constellations. I hope you take advantage of this and spend some time outside over the next couple of weeks as we're sort of enjoying the holidays. Dress warm, look up, and enjoy the sky in the winter. Thank you guys very much, and we'll see you in a couple of weeks.